Hello everyone, I am very pleased to share my work graph-based high-order relation modeling for long-term action recognition. From the perspective of the duration of actions, action recognition can be divided into short-term and long-term action recognition. Videos and short-term action datasets are usually pre-trimmed and last only a few seconds. The semantic in the pre-trimmed clip is simple, as it contains only one action. However, trimming short-term actions from true lifelong videos is very time-consuming and labor-intensive. In contrast to short-term actions, long-term actions are actions in untrimmed videos, which generally contains multiple sub-actions, among which some complex relations exist. The goal of long-term action recognition is to identify the long-term action, or to identify all sub-actions. Thus, only long-term action category labels or all sub-action category labels need to be provided, which will largely reduce the cost of dataset annotation. Therefore, long-term action recognition provides a feasible way for us to understand complex human behaviors. In the long-term actions, there are many important visual concepts, such as objects, motions, and sub-actions. Various relations may exist among these visual concepts, which we call basic relations. These basic relations will jointly affect each other during the temporal evolution of long-term actions, which forms the high-order relation. Therefore, exploiting the high-order relations from these basic relations is the key to recognizing long-term actions. For example, here the purple and cyan cues show two basic relation instances, and there are some connections between them. As the woman opens the book but then closes it quickly without reading it, we can infer that the picture is found from this book. Additionally, the woman does not put the book and picture back together, so she may go to look at the picture. Therefore, for long-term action recognition, it is important to model each basic relation well. More importantly, to exploit the high-order relations, the information from all the other basic relations should be incorporated while modeling each basic relation. The contributions of this work are threefold. A novel GHRM module is proposed to exploit the high-order relations from the basic relations in the long-term actions. A GHRM layer consisting of a temporal GHRM branch and a semantic GHRM branch is designed to model the local temporal high-order relations and the global semantic high-order relations. Our proposed model achieves state-of-the-art performance on three datasets: breakfast, charades, and multi-thumas, which demonstrates the effectiveness of our model. Here we show an overview of our proposed GHRM module. There are a total of k graphs for modeling k basic relations in the long-term actions. For each graph GHRM first calculates its adjacent matrix AI with the function GI, which would incorporate the information from all the other graphs. Then, the aggregated feature X aggregate I of the segment nodes in each graph GI is obtained based on its adjacent matrix AI. Finally, the new representation of the segment nodes X out I in each graph GI will be calculated by the embedding function rho I, which can also incorporate the information from all the other graphs. To better exploit the high-order relations in the long-term actions along the time dimension, our model constructs the GHRM layer based on the GHRM module. GHRM layer contains two complementary branches: the temporal GHRM branch, which reasons the graph locally to leverage the temporal context between neighboring segments, and the semantic GHRM branch, which reasons the graph globally to leverage the semantic context between segments without the limitation of temporal distance. As shown in these three tables, our GHRM achieves state-of-the-art performance on three popular long-term action recognition datasets: breakfast, charades, and multi-thumas, which demonstrates its effectiveness. Both vanilla GCN and the proposed GHRM module use multiple graphs to model the basic relations. Our GHRM can exploit the high-order relations by incorporating the information from all the other graphs, while the vanilla GCN fails to exploit the high-order relations due to the lack of information exchange between multiple graphs. To further demonstrate the effectiveness of modeling high-order relation on long-term action recognition, we replace our GHRM module with vanilla GCN for quantitative and qualitative comparisons. As shown in this figure, regardless of how many graphs are used to model the basic relations in long-term actions, our GHRM performs much better than vanilla GCN. This figure shows 8 adjacent matrices of a video sample produced by vanilla GCN and GHRM respectively. The adjacent matrices in vanilla GCN have very similar patterns, while the adjacent matrices in GHRM have diverse patterns. This phenomenon indicates that different graphs can interact with each other in GHRM, such that different basic relations will be figured out in the high-order relations in the long-term actions can be naturally exploited. That is all. Please see more details in our paper and thanks for listening. Contact me if you have any questions.